All right, this is video 10, composition of functions, simplifying expressions with variables. I'm joined by Mr. Nelson and Miss Johnson. I'm represented by the forces of good, Miss Johnson by the forces of evil, and Mr. Nelson is going to be our moderator. Hopefully this will be the last video in this unit, and then there'll be a test for this, and then there'll be a summative on everything. And if anything on these lessons that you don't get, please come on to Zoom to get anything you want clarified. So let's get straight to it. In the last lesson, Mr. Nelson did composition of functions. For those of you who didn't watch the last lesson, go watch the last lesson. That had to do with this little, not a dot, but an open circle stands for a composition or composite function. When we see that open circle, we know we have one. And in the last lesson, we were doing composition of functions with values, but this time we're doing with x, which in some ways makes it harder because some people hate multiplying x's and stuff like that, but other ways makes it easier because we don't actually have to solve as much as just simplify. So in this function we have f. It says I can solve equations using composition of functions. I'm given the function f of x equals 5x and g of x equals x plus 1, and the function says f of g of x. And so what's that saying is that we're going to be finding g of x because that's the order we're doing it in, and then after that we're going to find f of that. So that ends up being f of g of x. We're going to find x of g, and then we're going to find that value of f. So if I go and plug in x into g, well, guess what? X is already plugged into g. And let me change this to blue because that's what we need. X is already in g, so guess what? G of x literally equals x plus 1. I don't have to do anything with it. So in other words, I'm going to replace this and say x plus 1. So now I have f of x plus 1. That means that I'm going to go to the f function, and anywhere in the f function that I see an x, I'm going to replace it with this. And so people say, well, Mr. Craig, are you replacing an x with an x? I'm really not. I'm replacing the x value with x plus 1. So I go to the f function, and I'll put it to the side here, f of x plus 1. That's going to be 5, and then parentheses where we have the x plus 1. And then I'm going to plug in x plus 1. And is that being blocked by the video?
No, I can see it. It's all good.
You can see it? Good. All right. So now that I see that, I realize that in order to simplify this, I'm going to have to distribute because I can't add x plus 1. So I'm going to go 5. Oops. Maybe I should get a pencil here. I'm going to go 5 times x, which is 5x, and 5 times 1, which is 5. And so f of x plus 1 equals 5x plus 1. So what does that mean? That means f of g of x equals 5x plus 5. Because, again, we plugged x into the g function, and that was x plus 1. And we took the x plus 1 and we plugged it into the f function, and that gave us 5x plus 5. So f of g of x equals 5x plus 1. So now we're going to try that again.
You say plus 1, but you mean plus 5, right?
I mean plus 5. Did I say plus 1? That was up here. It's plus 5. I apologize. He's right. So now we're going to do that again. We're going to go g of f of x. And again, all we've done is switch around. Last time we did f of g. This time we're doing g of f. So we're just kind of flipping around just to show you that the change matters. So that means, once again, and this is the easy part of it, because I'm going to plug x into f, and I get f of x, right? And then whatever that equals, I'm going to plug that into g. So I get g of f of x. So, and what I meant by the easy part is that when I plug x into g, I end up looking at the f function, and x is already in g, isn't it? Because this is what f of x is. So f of x equals 5x. So all I have to do is simply replace the f of x with what it equals. It equals 5x. So I can go up to the top of the board here and go, I know that f of x equals 5x. And now I'm going to take that 5x and I'm going to input it into the g function. And the g function is x plus 1. So I'm going to go to the g function, and now I'm going to go g of 5x. And so this time I'm going to go in there, and people get confused because they see x's in both places. But remember, all along, Ms. Johnson and Mr. Nelson and I have been telling you that whenever you see an x, replace it with parentheses. So I don't care if this is a 5x or a butterfly or a flower or a steaming pile of poop. Whatever's in that parentheses goes into the empty spot. So I'm going to go to this where this x was, and I put parentheses and replace it with 5x. And now I say, okay, in this case, can I add 5x plus 1? And the answer is no, but I can drop the parentheses, so I know that g of 5x equals 5x plus 1 because variables come before constants. So the answer should have been g of f of x equals 5x plus 1. And you'll see that we have this little red box here, but all I did with this red box is I wanted to show you that the last one we had f of g, and we got 5x plus 5, but g of x gave us 5x plus 1. It's a different answer, so you got to be careful the order you do it in because you can get different solutions. So if you just got it right now and you're like, I get this, go ahead and try the activity. If not, we're going to keep going on these and try 2 more. So if you get it, you can stop here. If not, stick with me. So here's a new function. This one's a little bit harder. Everybody says that we don't give hard functions on the reviews and we don't give them on the activities. Well, here's one where it says f of x equals 3x and g of x equals x cubed plus 3. So this says f of g of x, so we know that we're going to be plugging x into g. That gives me g of x. And then I'm going to take that value, and I'm going to move this line, or I'm going to make lines on my lines, because that makes sense. And I'm going to take whatever that equals, and I'm going to plug that into the f function, which means I'm going to plug that into the f function. So f of g of x is f of g of x. And again, this is where the variable part comes in handy, because if I look at my g function, I already have an x there, don't I? So all I got to do is replace the x. I plug in the x in here, and I get x to the third plus 3. So this will be f times x to the third plus 3, because x is already in g. So now comes the harder part. I need to find f of x to the third plus 3. And you get scary for a second, but remember what we said. All you're going to do is you're going to go and replace the x with parentheses, and whatever you see in the parentheses, you're going to put there. So I don't care if it's a flower, a car, it doesn't matter. Your favorite person in the world's picture. Whatever's in there, you replace it. So if I come up here and say I want to find f of x plus 3, that means I'm going to go to the f function, which is right here, and go 3, and I'm going to put a parentheses there, and whatever was in those parentheses, I'm going to replace it. And in this case, it's x to the third plus 3. And so this goes back to, if you remember when we multiplied binomials, we made a area model. If this helps, this is the time where you could actually do an area model where you said, I have 3 times x to the third plus 3. And the only reason why I say this is to keep track of everything. When we multiply, let me go back to, when we multiply coefficients first. And so this one has an invisible 1. So 3 times 1 is 3. And then we bring down the x to the third. And 3 times 3 is 9. It's positive. And so this ends up being 3 to the x to the third plus 9. That is f plus 3. F of x plus 3. So that means that this equals
And Mr.
f
Krebs,
of, yes,
where you just underlined, you forgot to the power of 3, I think.
right here. Oh, you are right. Look at you.
Just caught that.
What would I do without the
Yeah.
power of that? All right, so f of g of x ends up equaling 3x to the third plus 9. And the reason why is because we plugged x into g, which was already there. We took x to the third plus 3 and plugged it into f, and that was this problem. And then we distributed that, and that's why I did the area model, and that gave us this value. So f of g of x equals 3 times x to the third plus 9. So that's kind of a creepy looking one. That's why we try to give it to you. And again, I always like to do them both ways just so you can see that there is a difference. So here is g of f of x. This means we're doing it backwards. Last one was f of g, and this one is g of f. So again, I'm plugging x into f, and so that's going to be f of x. And then whatever that equals, I'm going to plug that into the g function, which means I'm going to take this and plug it into the g function, right? So f of g of x equals f times f of x. And again, you can just do it this way if you want it with the arrows, or you can do it with this if you need to see it. So again, because we're dealing with variables, I can look at the f function, and the f function already has an x in it, so that's easy. So f of x equals 3x. And that means that I'm going to replace g of f of x, and f of x equals 3x, so I'll put a 3x. And then I'm going to plug that into the g function. And so the g function is this crazy thing right here. And remember though, all I have to do is if I'm doing the g of 3x, is anywhere I see an x, I'm going to replace it with parentheses. So in this case, I'm replacing x to the third power with parentheses and put the third power on top. And I'm going to put in there the 3x. And so this is where it gets confusing again, but if you remember from 8th grade, that, so I'm doing g of 3x, is I multiply the exponent all the way through, so 3 to the third power is 27, because it's 3 times 3 times 3. And x to the third power is x to the third. And then I have a plus 3. And again, is there anything there that's like terms? The answer is no. So g of 3 of x is 27x to the third plus 3, which means that g of f of x equals 27 to the times x to the third power plus 3. And so again, whoops, come on. If you look at our original, we had f of g of x. That gave us 3x to the third plus 9. But g of f of x gave us 27x to the third plus 3. So order matters, and that's one with exponents. Again, if you get this, do the activity. I just wanted to throw one more in there just to be silly and just to make you realize that all functions don't have to be f and g. You can label them with any letter you want, as long as it's kind of cursive-y, italic. So here's an example. It says, oops, I didn't want to do that. It says, I want to move this over because I'm guessing people can't see that very well. It says, I have the function p of x and t of x, and I want to find t of p. Get it? TP, in this time of need of TP. I found it. It's right here on this page. TP. All you want. Use it anytime. So again, if I'm doing a function, I'm going to be going, oh, I want to go to the p function first. I'm going to be going x into the p function. So that'll be p of x. And then whatever that equals, I'm going to plug that into the t function. And so I'll get t of p of x, tp. So again, like I've said before, this is the easiest part because we already have an x in the p function. So this p of x equals x plus 3. So I can replace p of x with what it equals, x plus 3. The way you can put it is you can put it up here. I know that p of x equals x plus 3, which means that I'm plugging x plus 3 into the t function, or right here I'm saying t of x plus 3. Either way is correct. And so now that means I have to go to my t function. And so I'm looking for t of x plus 3. And that function is right here. And so it's going to be 4, and I put parentheses in for wherever I see an x. And it doesn't matter that I'm putting an x into an x. I'm putting x plus 3 where I see an x. So I'm going to put in, I'm going to change the color just to keep this on track. X plus 3 is plugging in there. And then again, to simplify this, I'm going to need to distribute. 4 times x is 4x. And 4 times 3 is 12. And I bring down the minus 1. And so I think, oh, I'm done. But in this case, I actually have some like terms. I have 2 constants. I have plus 12 and minus 1. And 12 minus 1 is 11. So t of x plus 3 equals 4x plus 11. Which means that when I plug the x into the t function, that means t of p of x equals 4x plus 11. Again, this is a little bit confusing. I would try the activity. Please do it before Tuesday or the Thursday, whichever Zoom this falls on. And then you can come with questions that we can specifically answer or clarify for you. But you should really first try it to see where you're making mistakes, because we can't read your mind. We can only see what you've done. And then from there, we can figure out where you're making your errors. Hope this helps. This should be coming to the end of our units and the end of our year, which makes me sad that I'm not in class tormenting you. I'm here on the internet tormenting you instead. All right, everybody. Peace out.